Derivatives. What is a derivative? In short, they're basically the slope of a function at any given point when the function is a curve. So how do I find it? With this formula here, aka power rule, we can basically find a derivative of almost all functions. You'll see an example in the next slide. The derivative of any coefficient is just 0. You would bring the 2 out to the front and then subtract the 2 by 1, which would result into 2x. If you plug in any number in the x value, for example, if I plug in 2, I'll get the slope of 4. And if I move this, the slope at 2 is nearly, if not the same. Using what we learned before, we would pull the 6 out to the front and multiply it by the whole function before subtracting by 1. Next, we will move on to 2x, and it's also the same thing, but since it's basically x to the first power, it's multiplied by itself and, cancels out. And we do a bit of cleanup here until we get our final answer of 24 x to the 5th minus 2. Since any value to the 0 power will result into 1, we can assume it's just multiplied out. Product rule. You would use product rule to find the derivative when the original function requires multiplication, as seen with this basic template. To find a derivative, you basically take a derivative of the first function and multiply it by the second function as is, before you add it to first function as is, and then multiplying it by the derivative of the second function. Here's an example. We have x to the second minus 1 being multiplied by 3x plus 6. Here we have done product rule. The derivative of 3x plus 6 would just be 3, so you multiply it over here. And then the derivative of x squared minus 1 would just be 2x, and then you multiply it by the original function here. And then we should get something like this after distributing our values. And our final answer would be 9x to the second plus 12x minus 3. Of course, you can use the limit definition to find the derivatives of anything, but I don't think any sane calculus student would want to do all of that. Quotient rule. When the original function has division in it, to find a derivative of a function dividing by another function, you would first square the denominator before taking the denominator and multiplying by the derivative of the numerator. Afterwards, you would subtract with the derivative of the denominator multiplied by the numerator as is. Here's an example with x to the second minus 1 divided by 3x plus 6. Here, you can see that we square the denominator before having denominator being multiplied by the numerator, or at least the derivative of the numerator originally, before being subtracted by 3, which is the derivative of the denominator, being multiplied by the original of the numerator. After cleaning up a bit and distributing our values, we should get something like this. However, be mindful to distribute the negatives right here. Multiplying the negative here would make this negative, but to here, it would become positive, leading to this. And if we clean it up even more, we would get this function. If we want to be fancy, we can factor out a 3, and that's your derivative.